Adding and subtracting polynomials. Now, you learned during the lesson that there are different types of polynomials. There are monomials, binomials, trinomials. So the first thing you want to do is always identify what kind of polynomial you're working with. So I have a list of polynomials here, and I'm going to go one by one, identifying what type, what it is. The first example is a 3x squared. This here is a, I'm sure you guessed it correctly, monomial. It's just a simple term, 3x squared, nothing else is adding to it, nothing else is subtracting to it, therefore it's just a monomial. Our next one here is also a binomial. Now you may think, but miss, it doesn't have an x with it. Yeah, it is a unique type of monomial. This here is what we refer to as a constant. A constant will always be that number that is either positive or negative that is going to have no variable attached to it, like I like to say. There's no variable multiplying it. It's just a number that is positive or negative. That will always be referred to as a constant. Next we have a binomial. As you can see, this binomial has two monos. It has a 2x, which is a monomial, and it has a -7, another mono. So therefore, mono make a binomial. Same goes for the next example. And the last two examples are trinomials. If you notice, there are three terms. The first one is an x squared for this example. Then there's another monomial. There's another monomial. Three in total. That's where we get the word tri. There's three trinomial. Now you were also asked to write a polynomial in standard form. Well, what does standard form mean? Standard form basically means look at your problem and first identify what is the highest degree, as in which of these variables, and in this case we're talking about y, which of these terms that have y's have the highest power or has the highest power. Now if you notice, the highest power here is a 4, making this the highest degree, and making -2y with the fourth power the leading term, which is, that is how I'm going to rewrite my problem, starting with that specific term. So I start with a -2y to the power of 4. The next thing you do is, okay, well, what's after 4? Or what's before 4 in this case? The 3. So next we would use this term here and just write it right behind the first term. Next we keep going through the list. Okay, do I have a power of 2? No, I don't. But there is a power of 1, y to the power of 1. So that monomial goes after, and that leaves us with our constant, -9. This here is now written in descending order, which, as I mentioned earlier, this is standard form. Now comes the exciting part. We get to add polynomials. Now, this example, we are working with a trinomial, adding another trinomial. It is important to understand what kind of polynomials are we working with. Now you need to understand that this problem here can be rewritten as follows. All I'm doing is rewriting it without the use of parentheses. What allows me to do that is the addition symbol. If you see an addition symbol, pretend the parentheses don't exist, or pretend that the parentheses are not even there. So I rewrote the problem so you understand there's no need for parentheses. So the next thing you want to do is, what is the highest power that you're working with? In this case, the highest power is a 2. Now I have two terms that have the highest degree of 2. So those two terms, I will be writing them right next to each other. This is a horizontal method. That way you can see how we're going to end up with our final solution. So the next thing I'm going to do is, okay, what else comes after? I'm writing this in descending order, so I have a power of 2. Do I have anything that has a power of 1? Or any x term with a power of 1? So here I have x to the power of 1, and then I have another term with an x to the power of 1. So those two terms I will be combining, which, like I said, I'm going to rewrite them horizontally. And lastly, do I have any constants? I have a -3 and I have a +3. So those two I will write next to each other. So the last step, of course, is simplify. Combining my x squared terms, I have a -2x squared. Combining my next terms, the 5x and the 6x, I have an 11x, but this is a positive, so I'll put a plus. And at the end, -3 plus 3, my constants. Well, -3 plus 3 is 0, so I'm going to put a plus 0, but you must know that it is not necessary to write that 0 down. So the final answer is -2x squared plus 11x. Another example, again, the first thing you want to do is look at your problem. Since it's addition, pretend the parentheses are not there. So with that in mind, I'm going to look for the highest degree. I have a 3 here, and that seems to be the highest one. I don't see a degree of 4, meaning there is no power of 4. So I'm going to start with y to the third being the highest degree. Now looking through my problem here, I have y to the third, but then I have another term that is 2y to the third. So I know automatically that those two I will be pairing up, I will be combining together. Next, I keep going through my list. So after the 3, in descending order comes degree of 2, so power of 2. I have one term here, and if I look through the whole problem, it seems to be like that is the only term with a power of 2. So I will be using that next. Again, go down the list. After 2 is the power of 1. So I have a term with a power of 1. And if I go through the list, I'll find another term with a power of 1. So those two I will be combining together. And finally, I look for my constants. I have a constant here of -5, and I have another constant here of a +8. So those two will be combined together. The last thing you do is combine everything, combine your like terms. Now for my term of y to the third, keep in mind that this first y to the third has a 1 in front, so I'm going to use that to my advantage. 1 plus 2, add the coefficients. 1 plus 2 will make a 3. And keep what they have in common, which in this case was y to the power of 3. Next, I have 4x squared. The 4 is a positive, so put a plus sign, 4x squared. I will not be adding it to anything else because I did not have another term that also had the x squared. So that one was kind of a loner. Next, I have my y's to the power of 1. I subtract the coefficients. 3 minus 4 will give me a -1, and they have the y in common. And lastly, -5 plus 8, that gives me a +3. So now I have simplified everything, gotten my answer, and as you can see, it is written in descending order with the highest degree of 3. Now subtracting polynomials is a little different. Here you cannot ignore the parentheses. It is very important that you understand that when it's a minus, it changes everything. So some of you have learned that when you have a negative in front of parentheses, you're going to distribute it. So here we will be distributing the negative into a positive form, distribute the negative into a -5, distribute the negative into a +1. Now, my first trinomial, nothing changes here, but it's on the second that I need to distribute the negative. So what you could do is you could also add a 1 right there and multiply, distribute the -1. -1 times a +4x will result in -4x. -1 times -5 will give you a +5, and -1 times a 3x squared will give you a -3x squared. once you have distributed that negative or multiplied that by a -1, whichever you prefer, the next thing you want to do is look at your problem and look for the highest power. In this case, our highest power is the 2, the power of 2. So I will be combining those two terms because they have the same type of term. Okay, so I have written all my like terms together horizontally. Now I'm going to combine and get my answer. So I have 2x squared minus 3x squared. 2 minus 3, I subtract the coefficients. That gives me a -1x squared. Now you know that it is not necessary to write the -1, but you could. It's not wrong. Then we have -2x minus 4x. Again, subtract the coefficients because of that symbol, that minus. -2 minus 4 is a -6x. That's what they have in common. And of course, the constants, 3 plus 5, give you a plus 8. This is my final answer. It is written in descending order, which is standard form. Now the last problem that I'll be working out is also dealing with a trinomial subtracting another trinomial. Pay attention to the operation that is being presented or is being performed. Here we have subtraction. Now, subtraction means you cannot ignore parentheses. So we got to distribute that negative. ¿Para qué es eso? ¿Lo pago por teléfono o qué? Shit. I have combined all my like terms. So now I'm going to simplify. 4c to the power of 3, I have nothing to combine it with, so it stays the same. Same goes for -3c to the power of 2. I have nothing to combine it with, no other term. 7c plus 9c, and 8 minus 2, which is a positive 6. That is the final answer. Again, it is written in standard form.